By now we know how to find trigonometric functions of any given angle, but what if we have a situation where we need to find the trigonometric function of the sum of two or more angles? In this video, we'll derive the formula for finding the sine, cos and tan of sum of A and B angles in terms of sine and cos of A and B. Let the arrow of trigonometry OP trace out two angles A and B as shown. From the point T on E as shown. From the point T on ray OT at angle A plus B, we draw a line TP perpendicular to OA and call that point P. And from P, we will draw perpendicular PQ to the x-axis. TPO is a right angle triangle with angle TOP as angle B. Here we can see that TP is the perpendicular, OP is the base, and OT is the hypotenuse. And so we can find all the trigonometric ratios for angle B using the triangle. Similarly, triangle POQ is a right angle triangle with one angle equal to A. For this triangle, PQ is the perpendicular, OQ is the base, and OP is the hypotenuse. So again, we can use this to find the trigonometric ratios of angle A. We need a right angle triangle with A plus B as one angle. For that, we will drop a perpendicular from T to the x-axis and call it R. For this right angle triangle, TR is perpendicular, OR is the base, and OT is the hypotenuse. Let us see what will be sine A plus B from this angle. From the triangle TOR, it should be P upon H, that is TR upon OT. We should understand that trigonometric ratios and angle A and B can currently be expressed only in terms of sides of these two right angle triangles. OT is part of one of these triangles, but TR is not part. Hence, we'll do a clever trick here and drop a perpendicular from point T on TR and call this point S. The figure might look a bit complex in the first glance, but let's try to see the logic behind it, and for that, we'll deduce some relations between the sides and angles in this figure using geometry. SPQR is a rectangle, and so the opposite side lengths are equal, and obviously the corner angles are at right angle. Angle SPO is alternate angle of A, and hence they are equal. Angle SPO is also equal to angle STP. If you're not sure how, then try to prove that in a triangle, if you draw perpendicular to the base, this angle becomes equal to this, and this angle becomes equal to this. So the relations we will be using in our analysis are SR equal to PQ, and angle STP is equal to angle A. Now we can find the trigonometric ratios of angle A using the lengths of sides of triangle STP apart from OPQ, and OTP for trigonometric ratios for angle B. Hence, if we break TR as TS and SR, TS becomes part of one of these triangles, and SR, which is also equal to PQ, is also a part of it. So we finally get sine A plus B to be equal to TS upon OT plus PQ upon OT. Now is the time to do another mathematical jugglery. So we'll have to multiply and divide this term by TP and the next with OP. Take some time to look at this expression and try to relate it with these three triangles. You might have realized that the term TS upon TP is cos A, and TP upon OT is sine B, and PQ upon OP is nothing but sine A, and OP upon OT is cos B. This is the expression for sine A plus B. Now let's find cos A plus B. From triangle OTR, we can say OR upon OT is cos A plus B. To express OR in terms of sides of the triangle containing one angle is either A or B, we write it as OQ minus SP. So cos A plus B becomes OQ upon OT minus SP upon OT. Now we'll do a similar manipulation as we did for finding sin A plus B. We will multiply and divide this term with OP and the next with TP. Hence we get cos A plus B to be cos A into cos B minus sin A into sin B. To get tan A plus B, we simply divide sin A plus B by cos A plus B. Dividing numerator and denominator of tan A plus B by cos A cos B, we get tan A plus B equal to tan A plus tan B upon 1 minus tan A into tan B. Similarly, we can find cot A plus B equal to cot A minus cot B upon 1 plus cot A into cot B. So we have learned if we know sine and cos of the angle A and B, we can find sine and cos of A plus B. Now let us solve a problem based on the concepts learned. We have to find the value of sine 75 degrees. Given that we know the value of sine and cos of angle 45 degrees and 30 degrees. Here we can write 75 degrees equal to 45 degrees plus 30 degrees. So sine 75 degree is equal to sine 45 degree plus 30 degree, which is equal to sine 45 degree cos 30 degree plus cos 45 degree sine 30 degree. Now we know the value of sine and cos for 45 degrees and 30 degrees. So sine 75 degree becomes 1 upon root 2 into root 3 upon 2 plus 1 upon root 2 into 1 upon 2, that is root 3 plus 1 upon 2 root 2.